So after the selection of the study area, then first of all we have worked with the evapotranspiration, or better say the potential evapotranspiration for our observed station Daltonganj. After that, we have worked with the rainfall data. So these are the information which I actually made the video in the part 1 section. So this is the data about the monthly potential evapotranspiration according to Penman-Montet equation. Now the second one is the rainfall. So this is the available information for the rainfall. Now if I come to the crop section, then I am going to open. So for the part 1 lecture, I have selected maize. So once again, I am just repeating that stage. So I have selected the maize. Now the most important thing is that this Kc value, which I have already discussed in the part 1 lecture. This Kc value means what is the efficiency of the crops to utilize the to utilize the water for their growth and survival. It means how these maize crops at the initial phase, developmental phase, mid season phase, late season phase, how the maize crops are utilizing the water. It means their utilization capacity of the water is being reflected in the Kc values. The higher Kc values means the crops are very much potential or effective in utilizing the water. Okay. Now at the initial phase and in the late season phase, the values are found to be 0.30 and 0.35 respectively. It means the maize crops are not very much suitable, or they have their less ability to utilize the soil moisture which is available to them. Okay. Now here we are getting the number of the stages, number of the days. It means at the different stage, initial, development, mid season, late season, how many days are involved for the cultivation of the maize. There are total 125 days are involved in the cultivation of the maize. And generally, according to the formulation of the simulation by FAO, the planting date is somewhere in the month of February, and it is being harvested in the month of June. Okay, so that particular total duration is being shared within this number of days. So that is the most important thing. It means this number of the days, approx 5 months, are shared in the initial phase, developmental phase, mid season, late season, and the total number of days are 125. Okay, so this is the scenario of the crop. Now the other most important thing is that what is the rooting depth. It means it is assumed that the crop roots of the maize are found to be at a depth of 1 meter from the ground surface. That is a quite higher value. 1 meter is not a matter of joke. Here the roots of the vegetation are penetrating at the depth of 1 meter to avail the moisture which is available to those particular crops. Okay, however, what is the critical depletion? It means what is the rate of depletion of moisture in the soil. Those are being indicated by these values. Higher values means if in the late season phase the values are encountered to be 0.80, it means there is a higher depletion of the moisture. So the vegetation, it means the crop should be very much effective to utilize the water. It means that the depletion of the water rate is very high, and the crops are found to be in a very efficient mode to utilize the water. And now what is the yield response? The yield response are found to be higher. It means with the help of the available climate, available rainfall, available evapotranspiration, what is the potentiality of the crop to be grown. So that is the indication of the term yield response. So yield response is found to be higher at the phase of mid season, where the value is encountered to be 1.30. It means there the yield response is found to be maximum. Automatically the number of days are also found to be higher in the mid season phase. Okay, now the crop height, uh, that is the simulated value, the value is found to be 2 meter. Now that was the scenario for the crop. Now if I go to soil, now again the soil window is empty. Now if I go to open, here also our choices are limited. Now FAO categorize the entire country into these soils. So out of those particular category of the soil, we have to select that our study area is composed of which particular type of the soil. That is the most important thing. Now, if you are not satisfied with this category, if you double click onto FAO folder, these are the three generalized categorization of the soil, where you can select either heavy soil, light soil, medium soil, depending on the study area. So, in the Daltongan section, the soil type is basically red sandy loamy soil. So I have selected that one. Now click on open. So the soil has been selected. Now the total available moisture, it is the 140 millimeter per meter. It means within the depth of 1 meter, the amount of the water is, better say the rainwater is 140 millimeter. Now the maximum rain infiltration rate is 30 millimeter per day. Okay. Now, if you multiply 30 with the number of days in a particular month for which you are making the study, so we will get the total amount of the infiltration rate for that particular month. It means, suppose we are studying for the month of March. So, in the month of March, the total number of days are 31. So, if we multiply 30 by 31, we will get the total amount of the water that is being infiltrated total for that particular month. Okay, now what is the maximum routing depth? These informations are available over here. Now, if I go to CWR, it means the crop water requirement. This tables has been automatically generated because of the information which we have provided in the climate, in the rainfall section, in the crop section, in the soil section. So automatically, after getting those information, the CROPWAT has very efficiently identified that what is the amount of irrigation water that will be required for the growth of that particular crop. Now the most important thing is that here, not the name of the month has been mentioned a single time. Here we have categorized the month. Say for example, the month of February has been mentioned two times. It means if there are 20 or 28 days are there in the month of February, so if or you can directly categorize or segregate that month of February into two halves, maybe 14 14, maybe 14 and 15. So based on that, we have categorized this one. Now if you consider the month of the March, it has been mentioned three times. So in the month of the March there are 31 days, so the division may be like this: 10 days, 10 days, 11 days, to get the exact number 31. Similarly, for the month of April, there are three numbers are there: April, April, April. So in the month of April there are 30 days. So for each segregation there are 10 days: 10, 10, 10. So ultimately it will become 30 days, right? Okay, so based on the calculation of the evapotranspiration effective rainfall, here we have not calculated the total amount of the rainfall. This is the effective rainfall which we have calculated in the climate section. Here, after putting the values of the rainfall, after the selection of the station, we got the values of the effective rainfall. So what was the meaning of the effective rainfall? Effective rainfall means out of the total amount of the rainfall, how much amount of the water is being effectively utilized by the crops for their growth and survival. So that was the scenario of the effective rainfall. Again, I go to CWR. So this irrigation water requirement is in millimeter. Okay. Now, on the basis of these KC values, evapotranspiration values, effective rainfall values, we have calculated all these things. Now, the total irrigation water requirement for the cultivation of maize from time period for the month of from the month of February to the month of June, the total irrigation water requirement will be 502.8 millimeter. Okay. Now, the amount of the effective rainfall is 145.1. So, this is the effective rainfall amount 145.1, and the potential evapotranspiration value is 6 to 5.1. So the potential evapotranspiration value is considered to be the outcome of the water. It means those are the outgoing water. Those water is not utilized by the crops. So if you subtract the value of the 145.1 from 6 to 5.1, you will get this value, 502.8. So this value is closer to this value. Okay, now what is the expression of that? It means from the total evapotranspiration value, if you subtract the value of the effective rainfall, the remaining amount will be the irrigational requirement. Now, in the calculation of the irrigation water requirement, another most important thing will be the amount of the dew water that is being added to that particular crop. So that is not mentioned over here. Here we have just subtracted the value of 145.1 from 6 to 5.1. But here we have not calculated the amount of the due, but in the case of the irrigation water requirement, that value has been indicated, or that value has been considered. Okay, so that irrigation water requirement, it means for the cultivation of the maize from the month of February to June, this much of water will be required as a irrigation. Okay, now if I go to schedule, so this is the irrigational schedule position. Now need not to copy that table, you will just go to chart and you will go to this diagram. So after getting this diagram, a very important thing is that one is the total available moisture, this green color line, that is the total available moisture, and the red color line is the readily available moisture. What is the meaning of that? Total available moisture means it is the total amount of the moisture that is present within the soil. Red color line, or you can say this brown color line, means it is the readily available moisture. It means the amount of the water that is being utilized by the maize crop. So it proves that the total amount of the moisture available in the soil will not be utilized by the maize crops totally for their growth and survival. So there is a gap between the ram and tam, total available moisture and readily available moisture, and that has been indicated by the depletion of the water. So we need to identify at which stage from the date of planting. So this x-axis is indicating the number of the days from planting. So you can automatically identify the amount of the water depletion from the number of the days of planting. So the amount of depletion is found to be higher at the 41 to 42 days. Again, the rate of the depletion is higher from the 96, 97 days. In that days, the amount of the depletion is higher, while the depletion is found to be lesser in that section, in that section, in that section, that section, that section. So it means the depletion of the water is identifying that the total amount of the loss of moisture from the soil by the different activities, or from the crop as well by the different activities, maybe potential evapotranspiration, maybe by evaporation. So if you want to identify the irrigation amount, irrigation water requirement amount, the depletion of the moisture, the difference between the readily available moisture and the total available moisture, CROPWAT is the best, uh, you can say, the simulation model to identify the irrigation water requirement for a particular crop. Thank you all of you for your patience.